Hello everyone, welcome to the solution of GATE 2021 EC Signals and Systems question number 40. The question is, for a unit step input U of n, a discrete time LTI system produces an output signal 2 delta of n plus 1 plus delta of n plus delta of n minus 1. Let y of n be the output of the system for an input half to the power of n U of n, then what is the value of y of 0? The reference to this question can be found in Principles of Signals and Systems, Week 3, Lecture number 13 to 16 by Professor Aditya K. Jagannathan. So let us look at this question first. Let us try to understand the question. So we are given an LTI system H of n. And for a unit step input U of n, what is the output? The output is 2 delta of n plus 1 plus delta of n plus delta of n minus 1. And let y of n be the output of the system for an input half to the power of n U of n. The output will be y of n. And the question is to find y of 0. So what will the approach to solving this question? The approach will be to first find the transfer function and then find the LTI system. And once we have the impulse response of the LTI system, we can find the output for any given input, and our given input is half to the power of n U of n. And to find the impulse response of the system, we have two approaches. The first one is you take the Z transform of the output 2 delta of n plus 1 plus delta of n plus delta of n minus 1. You find the Z transform of the step input U of n, and then find the transfer function, and then find the inverse Z transform of the system, and that will give you the impulse response. So this is given in our useful data, and number one is the Z transform of a discrete time signal x of n is denoted by x of z and is given by capital X of z is equal to summation of n is equal to minus infinity to infinity x of n z to the power minus n. And second point, if the step response of a system is denoted by S of n, then the corresponding impulse response is given by the first difference of the step response. That is, the impulse response H of n is given by H of n is equal to S of n minus S of n minus 1. And the third point is delta of n minus n naught convolved with X of n is equal to X of n minus n naught, and where delta is the delta function, and k of delta of n into X of n is equal to kx of n, right? So let us first use our Z transform approach to solving this question. Okay, so the input is U of n, and let us denote its Z transform by U of z, and is given by Z of z minus 1, Z by z minus 1. Okay, and what is Y of n? We take the Z transform of Y of n and is given by 2 z plus 1 plus z inverse, right? Because Y of n is 2 delta n plus 1, whose Z transform is 2 of z plus delta of n plus 1, and plus delta of n minus 1 will be z to the power minus 1, right? So what will be H of z? H of z will be given by 2z plus 1 plus z inverse divided by z into z minus 1. Okay, and this will be given by z square 2z square plus z plus 1 into z minus 1. And we further simplify this as 2z cube plus z square plus z minus 2z square minus z minus 1. This gets cancelled out, divided by z square, and we are left with 2z. Okay, 2 of z plus z square minus 2z square will be minus of z square divided by z square will be minus of 1 minus of z to the power minus 2, right? Minus of z to the power minus 2, correct. So writing down it here again. So will be 2z plus z square minus 2z square will be minus z square divided by z square will be 1 minus z to the power minus 2. And now what will be the impulse response of the system, which will be the inverse Z transform, and this is given by 2 delta of n plus 1 minus delta of n minus delta of n minus 2, right? So this will be your impulse response of the system. And there is a different approach to finding this impulse response of the system, which is given in our useful data point number 2, which says that h of n is equal to s of n minus s of n minus 1. And since it is given in the question that the input is a unit step input, then s of n will be given by the output of the system, that is 2 delta of n plus 1 plus delta of n plus delta of n minus 1. And therefore h of n is equal to, so this is first point. Second point is h of n is equal to s of n minus s of n minus 1, right? And s of n is 2 delta of n plus 1 plus delta of n plus delta of n minus 1 minus s of n minus 1 will be replace n with n minus 1. Therefore it will be 2 delta of n minus 1 plus 1, it will be 2 delta of n plus delta of n minus 1 plus delta of n minus 2, right? So it will be 2 delta of n plus 1 plus delta of n minus 2 delta of n, so it will be minus delta of n minus delta of n plus 1 plus delta of n plus 1 cancels with minus delta of n plus 1, and finally we are left with minus delta of n minus 2. So as you can see from the two equations in these boxes, that they are both and the same. So you can go with either approach, and this is an easier approach where we know that by property of the Z transform that the h of n will be the s of n minus s of n minus 1, right? So now that we know the impulse response of the system, we can easily find find the output y of n, and y of n will be what? Y of n will be the convolution of x of n and h of n. So what is x of n? X of n is half to the power of n u of n. And what is our h of n? H of n is 2 delta of n plus 1 minus delta of n minus delta of n minus 2, right? 2 delta of n plus 1 minus delta of n minus delta of n minus 2. So y of n will be x of n convolved with h of n, and that will be half of n u of n convolved with 2 delta of n plus 1 minus delta of n minus delta of n minus 2, and this will be half, this convolved with this will be half of, you replace n plus 1 with you replace n with n plus 1, so it will be n plus 1 of u of n plus 1 minus, this will be the same, half of u of n, half to the power of n u of n minus replace n with n minus 2, and that will be half of n minus 2 u of n minus 2. So we finally have our output y of n. And now what is the question? The question is, what is y of 0, right? What is the value of y of 0? So y of n, we have it, so y of 0 is, you replace n with 0, and that will be So I'm missing 1 2 here, right? So half to the power of n into 2 into this. So it will be half to the power of 1 into 2 into u of 0 minus half to the power of 0 u of 0 minus half to the power of minus 2 u of minus 2. And u is a unit step input, and therefore it will be 0 for negative values, and this will be equal to 1. This will be also equal to 1, and therefore half to the power of 1 into 2 is 1 minus half to the power 0 is 1, and therefore it will be 0. So y of 0 is equal to 0. So this is your final answer. So the value of y of 0 is 0.